Hi, Algebra 2. We're going to get started with section 2.8, two-variable inequalities. So, graphing linear inequalities in a coordinate plane. Okay, we're going to jump over to the right. We're going to need to summarize the steps. If you remember, as soon as we see inequalities, we need to first graph the boundary line. Okay, and then with the boundary line, we're going to look at, is it solid versus dotted? So if you see the symbols there, solid, if it has an equal to sign under it, we're going to draw a continuous line all the way through. And if it has no equal to, then all the points on that line are not supposed to be a solution. So we're going to use the dotted line. After we shade the boundary line, we're going to shade half of the plane. In order to decipher which side of the plane we need to shift on, we're going to test a point, and hopefully a point that's not on the plane, hopefully on one side. The best point to always choose is 0, 0. Now, if 0, 0 is on your line, go ahead and choose either like 1, 0, 0, 1, or you can even go negative 1, 0, or 0, negative 1. If the statement is true, we're going to shade that half that the point was on. If the statement is false, we'll shade the other half. On the first one, it's already set up in y equals mx plus b. So we have the y-intercept right here. Okay. So we're going to go ahead and go up 1. There's our point. Now from there we can go up to right 3. We have a point there. Now I can also go down negative and over negative, which is also positive 2 over 3. So if we go down 2 and then over 3, it puts us in this lower left-hand spot. If we draw our line, we need to make sure, if you notice, it's not equal to, so it's a dotted line. There's our line. Now if you notice, 0, 0 is not on the line, so we can go ahead and use 0, 0. So if we check 0, 0, we plug in 0, 2/3, 0 plus 1 is 0 less than 1. That checks out yes. So we're going to shade the side of 0, 0, which would be everything below. Number 2. It is also in y equals mx plus b. If you notice, it is an equal to sign. So it's a greater or equal to. So we're going to have a solid line this time. We know because of the plus 0, we're going to start right at the origin. And then we can go associate this negative with up or down, so put it on top. So let's go down 1, right 2, puts us here. Down 1, right 2, puts us here. If we start back at the original origin, let's go up 1 but left 2, gives us here. Okay, and now the point that we check, we can't check 0, 0, so let's check 0, 1, which is just above. We check 0, 1, the y is now 1, greater than or equal to negative 1/2 times 0 plus 0 is 1, greater than or equal to 0. Yes, so that checks off, so we're going to shade above. Number 3, notice it's in standard form. Well, you can solve for y, or you can hopefully plug in and get the x and y intercepts. Sometimes that's easy. So if we plug in 0 for x, so 0 for x, it's going to give us negative 3y less than negative 12. Divide by negative 3, and you get y. Flip the sign, and 4. So you get 0, 4. And if we plug in 0 for the y, we'll get 4x. So we get negative 3, 0. Now we have 2 points. We can connect the dots. It is not equal to, so it's a dotted line. And there's our graph. 0, 0 is not in or on the line, so let's check 0, 0. 0 minus 0 less than negative 12. Is 0 less than negative 12? The answer is no. So we're going to not shade below the line, we're going to shade above the line. Go ahead, hit pause, do 4 and 5, check back with me in a second. Welcome back. Let's look at number 4. Notice there was only one variable, the x. Therefore, we should know that all the x's are going to be negative 2. So it's a vertical line at negative 2. And then you have to ask yourself, on the horizontal line, that's a bunch of x's. we want all the numbers that are greater than -2, which is to the right, or even if you plug in 0. So there's 4. On 5, hopefully you distribute through. Notice again, there's only one variable. This time it's a y, so it's going to be a y equals line, horizontal. If we divide by -6, don't forget to switch the sign. So we want all the y's that are greater than 3. So if we go up to 3 on the y, all the y's that are greater than that are above. Moving on to a little more complicated now. Not necessarily linear, but we're looking at absolute value. If you remember, yes, absolute value is a V shape. So all 3 of these graphs are going to be V shape, but they're going to involve solid dotted lines and shading. So if we start with the first one, if you remember from, I believe, 2-6, 2-7, we have the parent function, which is actually there. So its vertex is on 0, 0, and it's going to go up and over 1, and up and over 1, and up and over 1. Same thing with negative. Put in a negative number, it goes up to that because of the positive. Notice it's a solid line. From there, a point that is not on the line. Let's choose just this point right here. So 0, 1. If we plug in 1 and take the absolute value of 0, is 0 less than negative, or is 0 less than 1? And the answer is yes. So we're going to shade inside that V. So these will be all the points that satisfy that equation. Number 7. If we look again now, if you notice, we have changed the parent function inside. So that, yes, is a transformation slide to the, hopefully you're thinking to the left. You know, in other words, what can you plug in for x to make the +2 0? And that's -2. So we're going to go over 1, -2. Okay, and it's going to be going up from there. There's no other transformations, shifts, stretches, compressions. Okay, so if we were to, for instance, plug in 0, you'll get 2. So it goes up 2. And then if we were to plug in -1, you'll get 1. If we were to plug in -3, you'll get 1 also. So there's the formation of our absolute value. Because it's a not equal to, it's going to be a dotted line. Now notice you can choose 0, 0 since it's not on the graph. So if we plug in, is 2 greater than 0? Check mark, yes. So we're going to shade everything on the outside of this. Okay. Go ahead, hit pause. Number 8. Notice there was no shift inside the absolute value, so it did not shift left or right. It only went up 2, so the vertex moves from 0, 0 to 0, 2. And then when we check 0, 0, you get a false statement. So we cannot shade the side of the 0, 0. We shade inside the V. Now we want to take it a little further and go backwards. We want to write the inequality for each graph. So you're given the graph. Now we want to rewrite, hopefully use our parent functions to rewrite the actual inequalities. Notice on number 9, it is a single y equals mx plus b. So we're going to think in this terms, y equals mx plus b. And because it's dotted, it will not be an equal to. So it's either going to be less than or it's going to be greater than. Okay? And we didn't shade the side of 0, 0. We shaded the other side. So if we take our 2 points, we know it's y. Our point 1 that's on the far left, we're going to go down. Looks like we're going down 4 and then over 1. So we can say -4, 1, x, and our y-intercept was +3. So that's where we're starting off right now. So now we just have to figure out the sign. We know it's not an equal to, so we're going to use a less than or a greater than. If we write our y equals, if you notice it's a negative slope and we're going down 4 and +1, so we're going to get -4x, and it is actually going through the y-intercept at 3. So we have y something -4x plus 3. If we were to use just the point 0, 0, notice 0, 0 is not shaded, so it's a false statement. So if we were to plug in 0 for y and 0 for x, you get 0 and a 3. In order to make a true statement, it's going to be less than, but we don't want a true statement. So we're going to flip that, and the inequality is y is greater than negative 4x plus 3. Okay, the second part, if you notice, we have two horizontal lines and then shading in between. Horizontal lines are y equals. So we have y, and the first one is at 3. So we have y and 3. And then the second one is at negative 2. So we have y and negative 2. Okay. The top one is a solid line, so it has an equal to. And the bottom one is a dotted line, so it doesn't have an equal to. Well, if you look at the y's, where did we shade in regards to the 3? We shaded below. So we're going to say y is less than or equal to 3. But we also shaded above, so we're going to say but the y's are greater than negative 2. One way of actually writing this, because this is a system or 2, is we can say that negative 2 is less than y, which is less than or equal to 3. And the last one, go ahead and hit pause. Try that. It is an absolute value though. Welcome back. You should have gotten y less than 1/3 times the absolute value of x minus 3 plus 0. There is no shift up or down. There is a shift to the right, so that means the opposite of that positive is a negative. And if you notice that the v is somewhat compressed, so that means we're going to have to multiply some fractional part less than 1. Ends up being 1/3. And number 10. Now let's put this all together for a word problem. Salesperson sells 2 models of a vacuum cleaner. Or 2 models of vacuum cleaners. One brand sells for $150 each, and the other one sells for $200 each. The salesperson has a weekly sales goal of at least $1,800. Write an inequality relating the revenue from the vacuum cleaners to the sales goal. Okay, if we then graph the inequality. So the first thing we need to do is we need to notice that we have 2 brands. We're going to say brand 1 vacuums, brand 2 vacuums. The one thing we do know is if we're going to sell these vacuums, so here's our x, here's our y, okay, we have to actually sell more than 0 to make a profit. So we have a couple formulas that we're going to call common sense. So if we said, okay, we could call one brand, x could be your brand 1. So brand 1 vacuums is our x, brand 2 is our y. We know that these sell for $150 and these sell for $200. Okay. So common sense, we're just going to put down here is x and y has to be greater than or equal to 0. Now they could be 0, but if one's 0, then the other one's going to end up being a lot of money too. So we have that. And then the other one says, there's one more equation that says that if one brand sells for $150 each. Well, if we take $150 times the amount of vacuums we sell and add that to the $200 times the amount of the other vacuum, okay, we need to at least is greater than or equal to $1,800. And there's our 3 equations. Okay, so we know right now that whole box is shades. In other words, hopefully we can sell everything to the right, so that's greater than 0, and everything above the x is greater than or equal to y. So that leaves the one equation. If we take hopefully the x and y intercepts, if we let x equal 0, and we take 200 y greater than or equal to 1800, divide by 200, and you get y greater than or equal to 9, or 0.9 is 1 point. So we go up to 9, put a dot, and if we do the same thing, we let y equals 0, you get 150x greater than or equal to 1800, divide by 150, and you get x is greater than or equal to 12. So our 2 intercepts are 0.9 and 12, 0. Going to put a point. If we connect the dots, okay, it's going to be a solid line. We need to figure out, well, what side. Let's just use the 0, 0. Plug in 0, 0, so it's 0 times 150 plus 200 times 0. Is that greater than or equal to 1800? The answer is no. So we're not going to shade left or below the slanted line. We're going to shade above. If the salesperson sold exactly 6 200 models last week, How many 150 models did she have to sell to make her sales goal? If we go up on the Y to 6, because that's the 6 to 200, and if we go over to the line, there happens to be 4 on the X, so we know we got to probably have 4. We could have more. If we use our equation, 150 X is what we want to find. 200, there were 6 greater than or equal to 1800. We have 150x plus 1200. 150x greater than or equal to 600. X has to be greater than or equal to 4 $150 models. Always remember, do your best, forget the rest. Bye bye.